Hello students, today we are going to do a quick revision about fourth chapter, states of matter. So what is solid? First of all, we have studied already matter exists in three states, solid, liquid and gas. So talking about solid, what is solid? As you know, hard molecules which are packed together, they are closer and that's why they are hard. The reason for their hardness is their molecules are very close to each other. So this is the reason that molecules of solids are hard and they have fixed shape. A rock will always look like a rock unless something happens to it. So as you can see here, the arrangement of molecules, the molecules are arranged in a very close or a compact form. So molecules of solid don't move much. They only vibrate and have a uniform arrangement. So we can say, looking at the structure of this solid, we can easily say that intermolecular spaces are least in case of solid and intermolecular force is maximum in case of solid. Examples of solid can be chair, table, book, or any other kind of object which does not change its shape easily unless you apply large force or you break it with some strong object. So, what is solid? Solid is something which have a strong molecular arrangement, compact structure, cannot change its shape, cannot be compressed, okay, and do not move much, only vibrate about its mean position and have a uniform arrangement. Now, when we talk about liquid, this is the second state of matter, liquid. Example of liquid can be water, milk, or any other liquid, cold drink, any juice, anything can be called as a liquid. So when we see the molecular arrangement in liquids, the molecules are not so compactly arranged. They have some intermolecular space in them. It is not like no intermolecular space is there. There is some intermolecular space, unlike solids. In solids, we have studied the intermolecular space is almost negligible, but in case of liquids, there is some intermolecular space, and hence they can move from their position. And intermolecular forces are little weaker as compared to solid in case of liquid. So if I say about intermolecular space, it is more as compared to solid. And if I talk about intermolecular force, which is also known as cohesion or cohesive force, so that force is little weak as compared to solid. So because of this reason, liquids can easily flow. They can change their shape. They take the shape of container in which they are kept. So we can say that they can change their shape. They are uh, they have fixed volume. The volume is fixed. We cannot say that in liquids the volume is variable. They have fixed volume. If you take 100 ml of uh, any liquid, then 100 ml of liquid will be there only if you take it in a glass, or if you take it in a bowl, or if you take it in some other object. So the volume will remain same. So we can say the liquids do not change their volume. They have fixed volume. Their shape can change and they take the shape of container in which they are kept. So they are called fluids. Liquids are called fluids. Okay, so what is liquid? It can be a mixture of more than one element or a compound, will take the shape of whatever container they are in. Their cohesive force makes layer molecules stick together. uh, Atom molecules in the liquid are little more spread out than those of solids, and move a little faster, or you can say they slide around each other. So talking about second state of matter, examples of liquid can be any solution, or if we talk about solvent, that is water, that is also an example of liquid. Liquid have very little or no compressibility. Okay, they are very less or almost negligibly compressible. Okay, they have little intermolecular space and more, means more intermolecular space and little intermolecular force. So when we see uh, about next, when we see about gas. So what is gas? Gases are everywhere. air, atmosphere, or any other gas like oxygen, carbon dioxide, hydrogen, chlorine, all these are gases. This is the third category of state of matter. Gases are everywhere. They spread out and full of energy. They are, you can say, diffusion of gases. Diffusion is there in gases. They take the entire volume available to them. Gases will take the entire volume which is available to them. They do not have any fixed shape, nor they have any fixed volume. When we look at the structure of arrangement of gases, we see they have very huge intermolecular space, and hence very less intermolecular force or cohesion, and hence this is a reason that they have more intermolecular space. This is the reason they undergo diffusion. Diffusion is a phenomenon of when a gas, it acquires the whole shape or the volume available to it. So diffusion is spreading of gases is known as diffusion. Also, gases have large compressibility as compared to solids and liquid, again because it has large intermolecular space available. Then gases are everywhere, atoms that are very spread out and full of energy. They are bouncing around constantly. They are the molecules of gas, they spread in random manner, very in a fast mode. Gases evenly fill the entire space available to them. If we are taking uh, a big container, then the gas will occupy that much big container which we have. Okay, for example, I'll explain you the topic diffusion. If you spray a perfume in one corner of the room, then slowly and slowly that perfume fragrance will reach to another corner of the room also. This is because gases spread to the entire volume available to them. Vapor is another name for gas. We can also call gas as vapor. So vapor is another name for gas. If we talk about the summary of this chapter, then we can say, as you see here this table, volume, shape, we talk about shape. Then the solids have fixed shape, liquids takes the shape of the container, and gases also take the shape of the container. Volume, the volume is fixed in case of solid, it is fixed in the case of liquid, but the gases do not have fixed volume. They fill the volume of the container or entire container. Particle arrangement is fixed in case of solid, very close. In liquid, it is random, but it is still close. And in gases, it is random, but very far apart. So we can say they do not have they have large intermolecular space. Then when we talk about how do two particles of the matter interact, so in case of solid, the interaction is very strong. In case of liquid it is strong, and there is no interaction between the molecules of gases, so essentially none. Then movement of particles very slow. The particles of solid when heated, they slowly vibrate about only their position. In liquid it is moderate, but in gases it is very fast movement takes place because of large intermolecular spaces in gases. Example of solid is ice, salt, iron. Example of or liquid is water, oil, and vinegar. An example of gas is water vapor, helium, and air. Now, when we talk about change in state of matter, the state of matter can change. Liquid can change to gas, gas can change to you can say liquid. So solid can change to liquid, liquid can change to gas, gas can again change to liquid, and liquid can again change to solid. So this is called change in state of matter from one form to another. So change in state is physical change only. There is no change in chemical composition. Example, solid ice change to liquid, and that water, liquid water, when it is heated, it will change to water vapor. Water vapor can again change to liquid on condensation, and that liquid can again be changed to ice on freezing. So particles move at a different rate for each state. So changing state means you must add or remove energy. So if something is melted, then slow solid becomes faster liquid. So of course energy is added. And if in the second case, freezing removes energy because faster liquid changes to slow liquid. So whenever there is change in state, there is always involvement of energy process involved. Always there is involvement of energy whenever there is change in state. If we talk about melting, then the state changes from solid to liquid and energy is added. Freezing, liquid to solid, energy is removed. Evaporation, liquid to gas, energy is added. Boiling, liquid to gas, energy is added. Condensation, gas to liquid, energy is removed. And sublimation, solid to gas, energy is added. Sublimation is a process in which a substance changes from solid state to directly from vapor state, like camphor, ammonium chloride, iodine are the examples. Melting means when ice change to water. Freezing means when water change to ice. Evaporation means I'm just giving an example. It is not the case of only water. Any liquid can undergo, or any solid or any gas can undergo all these processes. But when I talk about specifically evaporation, for explaining water changes to water vapor on heating. So heating kara to energy is added. Boiling, again liquid to gas, energy is added. Evaporation and boiling difference is evaporation occurs at a normal temperature, but for boiling we have to heat the mixture. In evaporation, we do not heat anything, like water is evaporating from water bodies. Sun's energy is evaporating that, but in boiling we are putting it on gas, or we are giving heat energy from outside. So that is the difference between the two process. And in condensation, example is condensation takes place in clouds. Formation of clouds is the reason of condensation. So in condensation, gas changes to liquid and hence energy is removed. Sublimation is directly changing of solid state to gaseous state. Like in the case of, we can say in the case of what camphor or ammonium chloride or any such things. So we are just doing a quick revision of that chapter. Everybody just go through the video repeatedly again and again. And if there is any doubt, you can ask me. I will be discussing it in the class.